Hi, Algebra 1. Here is a quick test review video for section 6.0 through 6.3. We're going to start by reducing these radicals. And when we reduce radicals, if we have a radical with no given index, remember that that index is a 2. And every single time when we start simplifying a radical, we will make a factor ladder because we need to know the prime factorization of the radicand. So here is 80. 80 divided by 2 is 40. 40 divided by 2 is 20. Divided by 2 is 10. Divided by 2 is 5. So we have 1, 2, 3, 4 powers of 2 and 1 power of 5. So the square root of 2 to the 4th, 5 to the 1st, f to the 10th, g to the 7th. From there, we are going to compare the index with all of those powers. So here goes. 2 goes into 4 2 whole times. 2 powers of 2 are coming out. No powers of 2 remain underneath. 2 will not go into 1. That is why the 5 to the 1st stays under. 2 goes into 10 5 times. The base never changes. F to the 5th comes out. 2 goes into 7 3 times, but 7 over 2 is 3 with 1 power of g left over. So this is the answer. We can simplify it by simply saying 2 to the 2nd is 4, 4 f to the 5th, g to the 3rd, square root 5g. Both of those are beautiful, correct answers. Let's do it again, this time with 432. So make a factor ladder for 432. It's obviously divisible by 2. So 432 divided by 2 is 216. 216 divided by 2 is 108. 108 divided by 2 is 54. 54 divided by 2 is 27. Divided by 3 is 9. Divided by 3 is 3. So 1, 2, 3, 4. 4 powers of 2. 1, 2, 3. 3 powers of 3. 3 powers of A. 4 powers of B. And 10 powers of C. Once again, we're going to be comparing the index with all of the powers. The bases always stay the same. 3 goes into 4, 1 whole time with 1 power of 2 remaining underneath. 3 goes into 3, 1 whole time, none left underneath. 3 goes into 3, 1 time, none left under. 3 goes into 4, 1 time with 1 power left under. 3 goes into 10, 3 times with 1 power left under. So what is the coefficient of the radical? 2 times 3, which is 6, A, B, c to the 3rd, and then the cube root of 2b, C. That is the simplified radical. We have 4 of these on our test tomorrow. Next, rewrite as a radical and simplify. So first of all, let's be reminded that the denominator of the fractional exponent will be the index of the radical. The radicand is going to be 81. It stays the same. And then, of course, we have all of it being raised to the negative 1 power. That numerator becomes the exponent. So from here, let's find the 4th root of 81. Hopefully by now you can visualize that 81 is 9 times 9, which is 3 times 3 times 3 times 3. So 81 is 3 to the 4th power. Simplify the radical just as we just did in the previous problems. 4 goes into 4, 1 whole time. So we are left with 3 to the negative 1 power. And of course, negative powers make exponents. So this is 1 over 3. So 81 to the negative 1/4 becomes 1/3 because we reciprocate negative exponents, which means we flip them. We're going to do the same thing with number 4. So this will be the cube root. The denominator of the fractional exponent is the index of the radical. The cube root of negative 27 to the second power. Now, we can take a cube root of a negative number because negative 27 is negative 3 times negative 3 times negative 3. Therefore, the cube root of negative 27 is negative 3. And negative 3 squared means negative 3 times negative 3, which will indeed be 9. So all of that goes to 9. We have 2 problems like that one on our test. Next, simplify using properties, not of radicals, but of exponents. I'm still in radical fault land. So simplify using properties of exponents. Remember, this is all multiplication, all the way across. So we can use the commutative property to help us out as well as the associative property. So all the coefficients go together. So in the first set of parentheses, negative 3 times 4 times 2. And then in the second set of parentheses, all the powers of x. X to the negative 3rd, x to the 4th, times x to the 6th. So right up front, we're just straight going to multiply. Negative 3 times 4 times 2 is negative 24. 8 times 3, negative 24. There you go. Next, I'm multiplying. The bases are the same. Add the exponents. So negative 3 plus 4 is 1. 1 plus 6 is 7. X to the 7th. Negative 24, x to the 7th, and that is the final simplified result. Number 6, something a little bit different. In number 6, if we're following order of operations, we have to deal with that exponent. There's nothing to do inside of the parentheses, but everything inside of the parentheses is getting raised to the second power. So we've got negative 5 squared. And then we've got powers being raised to a higher power. Multiply those exponents there. So we've got negative 5 squared. We've got a to the negative 3rd squared. That's a to the negative 6th. B squared squared. That's b to the 4th. C to the negative 4th squared. That's c to the negative 8th. That's all over 1. And everywhere that we have a negative exponent, we will be flipping it. This coefficient is negative, but its exponent is positive. It stays on the top. Negative 5 times negative 5 is 25. B to the 4th stays on the top. A to the 6th goes to the bottom. And C to the 8th goes to the bottom. We reciprocate negative exponents. Number 7, the big fraction. And maybe it will be helpful if we look at this in pieces. So first of all, let's focus just on the numerator here. If we're focusing just on the numerator, note that it's multiplication all the way across, even if we put the dots in or not. So let's rearrange this numerator so that it looks a little bit better. So first of all, we are going to put together the 24 and the 3. And you can even leave them factored because something's going to cancel. Now let's put the m's together. We've got m to the negative 3rd and m to the negative 2nd. M to the negative 3rd, m to the negative 2nd. All we're doing here is organizing. N to the 4th, n to the 1st. N to the 4th, n to the 1st. Then p to the negative 5th, p to the negative 2. I'm using the commutative property and the associative property to reorganize all of my parts of this problem. Now line things up here. So the 15 goes over 24 times 3. The m squared goes under. 15's under. M squared is under. N to the 5th is under. P to the negative 10th is under. I'm just spreading it out because now we've got smaller problems to deal with here that are much more manageable. So first of all, right up front, this 3 can cancel with the 15 5 times. And now we've simplified the first part. So we've got a 24 on top. We've got a 5 on the bottom. Next, we are multiplying and the bases are the same, so we're going to add the exponents, and we get m to the negative 5th over m squared. Next, n to the 4th, n to the 1st. Once again, we're multiplying and the bases are the same. Add the exponents, n to the 5th over n to the 5th. Next, multiplying, the bases are the same. Add the exponents, that's p to the negative 7th over p to the negative 10th. Once again, if it has a negative exponent, it has to reciprocate. So this m is to the negative 5th, it comes to the bottom. This p is to the negative 7th, it goes to the bottom. This p is to the negative 10th, it goes to the top. So we end up with, and also, n to the 5th over n to the 5th, that just cancels completely. They're gone. 5 minus 5 is 0. So finally here we're getting 24 over 5 m squared times m to the 5th. And then we have p to the 10th on the top and p to the 7th on the bottom. One last simplification here. 24 over 5, still hanging in there. M squared times m to the 5th. We're multiplying and the bases are the same. That's m to the 7th on the bottom. And then our final property of exponents is the quotient property. So if we have p to the 10th over p to the 7th, I'm dividing and the bases are the same. 10 minus 7 leaves p to the 3rd on the top. Now that is by far the most involved problem, and there will be one like it on the test. That's the most involved one. The key to this problem is organizing. Organizing the information. So maybe you need to watch this particular problem a few times. Finally, 2 last problems where we are adding or subtracting, leaving our answers in standard form. Both of these require use of the distributive property first. So I will be distributing a negative 3x squared, and I'll also be distributing a negative 1. Be on the lookout for that when there's a minus sign directly in front of parentheses. Negative 3x squared times 4x squared is negative 12x to the 4th. We're multiplying and the bases are the same. Add the exponents. Negative 3x squared times negative 5x squared plus 15x squared. Negative 3x squared times 6 negative, add those exponents. X squared times x to the 1st is x to the 3rd. That's a 3. So add those exponents. Negative 3x squared times 6, negative 18x squared. So 2 plus 2 is 4, 2 plus 1 is 3, and 2 plus nothing stays 2. We distributed the negative 3x squared. Now distribute the negative 1, negative 6x cubed, negative 5x to the 4th, and plus 7. Now let's corral the like terms. Here's an x to the 4th, there's an x to the 4th. Here's an x to the 3rd, there's an x to the 3rd. Then we have an x squared, and then we have a constant. Let's put them in descending order. Descending order has everything to do with the exponent. A negative 12 and a negative 5 is a negative 17x to the 4th. Mark them off. Next are the cubes. Positive 15 and a negative 6 plus 9x cubed. Mark them off. A negative 18x squared comes next. And then finally, the constant, plus 7. We're in descending order. 4, 3, 3, 2, and none. We want our exponents to descend. Last problem, number 9, distribute first, distribute, distribute. This is going to give us negative 1/2 x squared times 2x is negative x cubed. Half of 2 is 1. If you want to put the 1 there, knock yourself out. I added the exponents because the bases were the same. Negative 1/2 x squared times a positive 4, negative 2x squared. Keep going. Distribute. 1/3 x times 6x squared plus 2x cubed. 1/3 x times negative 3x, negative 1x. 1/3 x times 9 plus 3x. Keep going with the negative 4x squared. Negative 4x squared times x, negative 4x cubed. Negative 4x squared times 2, negative 8x squared. Organize your terms. X cubed, x cubed, x cubed. X squared, x squared. And then lastly, we have 2 x's. A negative x here and a plus 3x there. So x cubes come first in descending order. Negative 1x cubed plus 2x cubed is positive x cubed minus 4, negative 3x cubed. Mark the x cubes off. Next, the x squares. Negative 2x, negative 8x, negative 10x squared. Mark them off as you use them. And then finally, negative x plus 3x plus 2x. 3, 2, and 1. We want all of our answers in standard form, which is descending order according to the exponents. That, ladies and gentlemen, is your review for your Chapter 6.0 through 3 test.